Greetings, everyone. Good afternoon and good day, depending on where you are. Welcome on a keynote kickoff for the YR Foundation conference and also for the text mining hackathon. Please let us know where are you from. It's always good to know where the audience is from. And there's a chat on the right on the YouTube where you can post the cities or the countries. And today we have Julia Silge. That is our keynote, but before we start, I have a small announcement. So for the text mining hackathon, we just announced the challenges. We just announced challenges at the website. So if you go to yr.pl, you can find a section for the hackathon. This year, we are trying to fight the challenges of text mining. So we have a broad variety of challenges. There is more than one, so each team can adjust the level of advancement depending on the time that you have and the skills that you have. The list of challenges is visible on GitHub. You can also find the data sets there and a note that this year we will have heavily business circumstances during the hackathon, which means challenges might get adjusted or the data sets might change. You can also find competition rules as well. The people that are involved, which are our speakers, our mentors, and our jury. We have a sponsor, McKinsey & Company, that were great and made this even happen. And for the full length of the hackathon, we will have a couple of talks. We start with Julia, then tomorrow we have a talk by Ken, and we end the hackathon with a sponsored talk by McKinsey about their analytics team. So that's all from me. Let's get back to our keynote. So Julia is a data scientist and a software engineer at RStudio, known, doesn't like to be said famous, for text mining analysis and production of tools for machine learning. So you can also heard about Julia from her book and work related to text mining and tidy text and tidy models. And today we will have a chance to hear about a different passion than text mining, but I think this is really related, and we will have a chance to hear about data visualizations. So Julia, thanks for coming, and good luck with your talk. And let's have the questions at the end of the session. And people, if you have any questions, please put them on the chat, and at the end, we will ask Julia whatever pops to your mind. So good luck.
Great. Thank you so much for that introduction and for having me here. Thank you so much to the sponsors for making YR possible. I am really excited to be able to kick off YR this year. I'm excited to be speaking before the hackathon because text mining is one of the real significant interests that I have in the work that I do. What I'm going to be talking about today has important implications for text mining, but it's a little more general, a little more broad. I'm going to be talking about data visualization practices for people who are involved in machine learning, in just your everyday machine learning practitioners who are out there building models. Data visualization is one of the key communication tools we have when we're speaking outward, when we're taking results and we're saying, hey, what is it that I did? I'm going to communicate outward about my results. But what we're going to talk about today is another aspect of how data visualization is used. And it is that it is a tool to make better modeling choices. And it is a tool used by system designers and by the system operators themselves. So data visualization is a hugely important tool for all kinds of people who work with data, not just people who build models or work in machine learning. And a lot of what we're going to talk today is true because data visualization is so effective at surfacing information to human beings through our visual channel. We can learn and see and understand things. So when it comes to data, these visual ways of perceiving information form how we think about the work we're doing, how we understand the problems we're solving and the models we're building, and how we decide. I especially want to focus on data visualization as a support or an aid for decision making, because building models or machine learning systems is this complicated, involved task. And I want to frame the plots and graphs that we make the way Tamara Munzner does here. So we use our computers and the code that we write to represent the data sets. We make these visual representations of our data sets for a specific purpose when we're building models. So I thought of really broadly, that purpose is so that we as machine learning practitioners are more effective. We have a task that we're trying to do. We're trying to train models, and the plots that we make us more effective. So when it comes to models and machine learning, more effective can have a couple of different meanings. We can mean more accurate. We can mean more practically appropriate for the space that we're working in. We can mean more fair. And we're going to talk about a couple of these different ways of being more effective in machine learning and modeling. I work on an open source framework in R for modeling and machine learning called tidy models. And a lot of the examples I'll be showing you today are from models that I've trained using tidy models packages. I'm going to show some tidy models code. Some of the specific goals of the tidy models project are to provide a consistent and flexible framework for real world modeling practitioners, whether you're at the beginning of your path in modeling, you're learning, you're starting out, or you're an expert user. We have goals around harmonizing the heterogeneous interfaces within R, and a goal of encouraging good statistical practice through the design of tidy models and defaults and those kind of things. If you want to learn more about tidy models, you can head to tidymodels.org. And I'm glad to get to show some of what I work on and build. But a lot of what we're going to talk today isn't specific to tidy models, or to be honest, even to R itself. What we're focusing on is a little more broad. It's about how we use data visualization practices for real world folks engaged in models. So I want us to start by asking this question: when do practitioners build data visualizations? So asking this kind of question requires us to think about the process of model building, to build a mental model of model building, if you will. So I'd like to put out this schematic here as what might happen during a typical process of a modeling practitioner, getting from the point of first seeing the data to having a working model that then they go and they do something with. So the modeling process starts here with exploratory data analysis, or EDA. This is the systematic, iterative process of exploring data to investigate it. Next, here comes feature engineering. So this is the task of taking our original variables that we had and transforming them into features that are more useful for modeling, that will be better suited to the math that the model, whatever modeling algorithm we're going to use, is going to do. Then comes model fitting and tuning. Note, I've represented this here with lots of little lines because typically, when we are adopting best practices, we fit and tune many times on resampled data sets. And we typically try out more than one model. So we're seeing what kind of model is going to work best for the problem space that we're working in. At that point, we have multiple models, and the next thing we need to do is we need to evaluate the models. We need to measure how well these models perform using some metric that is appropriate to those specific kinds of models and the specific problem that we're working on. So notice that it doesn't stop there. This process is iterative. So we go through that process, we see what happened, then we go back and we do a little more EDA, because of some things we learned from the results, we say, oh, I need to spend some more time on feature engineering to be able to be better suited for the model. I'm going to come back to Model 2 and Model 4 because they were the ones that worked the best. And then finally, at the end, we'll end up with a model that we'll call our final model. Notice that this process ends with some goal or output. Either communicating the results if the goal is like, I want to learn something, or maybe deploying the results if the goal is to put this into some production system. This is a skinny bar here on this plot, but really picture that being like a transition to a whole other set of tasks. In this talk, we're gonna focus on the rest of this schematic before we get to communicating to others or deploying. And what I want to talk about is the fact that machine learning practitioners are free to make plots at any point during this process. But I want to make the argument that there are two phases of the modeling process where practitioners use data visualization the most. And the first is EDA. I said before that exploratory data analysis is this iterative phase of investigation, question generation, and refinement, and exploring. This phase is one that some people might put like outside of modeling and machine learning itself, but we're going to see how the investigations and understanding gained during EDA have a huge impact on models, on the choices that are made in building models. The second is model evaluation. This is the part of that modeling process that we had the schematic of, where a practitioner has trained multiple models and then is assessing or measuring or comparing how well they've performed. So if you were able to come and kind of like look over the shoulder of someone building a model, it's at these 2 points that you would see someone creating the most plots. And in my opinion, using visualization in a lavish, extravagant way at these phases of the process is a sign of health, is a sign of a process that is off to its best chances of doing well. The reason why is that those two phases of the machine learning process are the points of most important human decisions. Validation of those decisions can be difficult because often there is art, not science involved. Because really what it's about is that these are decisions that are full of trade-offs. And any individual model analysis, a practitioner is going to have to make choices, and say, hey, what's more important to me? This priority or this priority, and make trade-offs for one versus the other. And visualization is used as an aid or support to carry out those tasks more effectively and make those better choices. So let's dig a bit deeper and talk about how this happens more. And let's start with exploratory data analysis and EDA. And let's ask the question, why are these plots built? So at a very high level, these plots are built to understand the data. When a practitioner starts out on a modeling project, this is one of the first substantive tasks that's going to be faced by them. And the reason that we as practitioners need to have this understanding of the data is because there are about to be a whole bunch of decisions to make. And these data visualizations let practitioners ask and then refine specific questions related to the modeling goals, like what kind of model is appropriate? And this feeds into the feature engineering phase that we talked about before, and say, like, what kind of pre-processing is needed? And then we can ask things like, is there anything unusual going on with this data in terms of distributions or outliers? All these questions are ones that machine learning practitioners ask, refine, and answer by making plots during the EDA process. Let's look at a couple of example plots to see what these look like. So some of these plots take the form of very familiar statistical graphics, like this scatter plot here. So this plot uses a data set called the Palmer penguins. So it's penguins that have been observed in Antarctica near Palmer Station. And this plot maps each observation to a point on the plot with aesthetics like the positions, X and Y, the size, and the color representing things that have been measured about the penguins, like how deep or long the bill is for the penguins, the sex, the mass of these penguins. So exploratory graphics like this are important for machine learning practitioners because, for starters, they help us understand the type and amount of data we have available. And then going further than just that, they visually highlight relationships in the data that we can use in feature engineering or models. So if we want to build a classification model to predict the species or the sex of the penguins based on the other measurements that we have, the relationships that we discover or highlight or uncover in this kind of graph inform the steps that we can take moving forward. This box plot is another example of a very familiar statistical graphic that a practitioner might make during EDA before building a model. So the data set here is the set of all the episodes of the television show The Office. And that we have information, we have text information that we can use in building a text model. We also have information on character, appearances, who wrote and directed each episode, and so on, along with the IMDb ratings for each episode, which is what is on the y-axis. So if we want to build a model to predict that rating for an episode based on all these other characteristics, including maybe the text, we can use EDA to check out all different kinds of things, including, for example, what's shown here, which is there a seasonal pattern to IMDb ratings? Like are episodes early in a season rated higher or lower than episodes late in a season? Plots for EDA don't always look like those super classic statistical graphics. So this plot, in some ways, is just a scatter plot, but what is being mapped here in X and Y are spatial coordinates, and so it's a map. So this is a data set of trees in San Francisco, and that big empty area is Golden Gate Park, and some of those other empty areas are smaller parks. And the color maps to who is maintaining the tree, who is in charge of the tree, either the Department of Public Works in San Francisco or someone else. So if our goal is to train a model to predict the maintainer, a plot like this is gives us information right off the bat for someone creating the model. We understand that, hey, the trees in the parks are not in this data set. We can look at things like we can see, oh, this gives me information about what kind of model I want to try, what predictors I might expect to be important, and what am I learning here about the data set just from using this visualization as a tool in the process. So machine learning practitioners use visualization during EDA to make lots and lots of different kinds of plots. And because of that, it's important that the tools that we use for visualization during this phase facilitate fluent iteration through lots and lots of kinds of graphs. So in my personal experience with decades of various scientific plotting tools, I think what will get you really far in terms of efficiency is learning about and internalizing the concept of the grammar of graphics. That adopting a system that applies this grammar takes us like a huge step forward in efficiency in this kind of task of asking, refining, and answering questions. ggplot2 is, probably the best known system that implements this grammar of graphics. And the plots that you've seen here during this talk so far are plots that I made myself using ggplot2 and this grammar. So the idea of this, having this flexibility and being able to put together any plot that we might need to during EDA because of being able to put together a plot like the grammar of graphics, like a grammar lets you put together a sentence, is super powerful and worth learning to be able to use fluently. Once we've done all that EDA, we can, while we're doing that EDA, we are answering questions such as, what kind of model are we going to use? So let's think back to that example data on the office. So if we want to predict the IMDb rating, we might start from what was the most straightforward and basic option, which would be linear regression using ordinary least squares. So in tidy models, one of our goals is to harmonize the heterogeneous interfaces that we often find in, like the Wild West of R's modeling ecosystem. So what we do is we separate out the kind of model we want to train, which here is linear regression, with the computational engine we want to use, which here is LM from the stats package, meaning basic, ordinary, linear regression. However, when I was doing EDA on this data set, I found there were a ton of predictors, like just so many. In fact, so many that if you use ordinary least squares, we unfortunately have overfitting. We get a model that depending on what we have, we don't get good results. So I can use the fact that I knew about this really large number of predictors to try a regularized model to reduce overfitting. So in tidy models, I can fluently switch back and forth by what computational engine am I going to use, but use the same interface. If for a different situation from some other modeling, I might see during EDA that there's a lot of complex interaction between variables. And I might realize, a linear model is just not going to work at all here. There's too many complex interactions. And I instead might choose to use a tree-based model, like a random forest model is a good example of that. So the trees in San Francisco are a good example of when we might decide to do this. There were more variables in that data set than just latitude and longitude, but you could see even from that initial map that there were complex relationships there related to the outcome. And if you remember, that outcome actually was not a continuous variable, but it was a label or a categorical variable who was maintaining the trees. So we need to build a classification model rather than a regular one. And again, we can fluently change back and forth between these options. So this might be just the most basic thing that we can start with when it comes to setting up a modeling analysis. But even this is something that model practitioners learn from EDA, often through visualization. What kind of model is appropriate? The next step often is what kind of decisions are we going to make for feature engineering? In tidy models, we capture data preprocessing and feature engineering in the concept of a preprocessing recipe that has steps. So you define, as this illustration so wonderfully shows, we say what variables we're going to use, then we define the steps and prepare them using some training data. And then after that, we can apply them to any new data set, like the testing data or new data when it comes time to make predictions. So protecting against data leakage during data preprocessing is a defining feature of the design of tidy models. The specific feature engineering steps are typically chosen because of what we learn during EDA. Let's look at another example of this. So this is a data set of houses in Ames, Iowa. So we have a lot of information about the house characteristics, like how big they are, where they are located in the city, and their last selling price. So this plot shows the sale price on the y-axis and latitude on the x-axis. So there's a big hole there, and that's where Iowa State University is. And then we see kind of some unique and complex structure and price as you move across the city. That's related to different neighborhoods, you know, how close or far something is to, you know, downtown versus the university versus other things. So if we want to, you know, capture that information in a model, there's a lot, you know, there's a number of options we could pursue, but one way to do that is to use splines to build new features, to do feature engineering for modeling. The thing is, though, we have to decide how many spline terms to use. So 2 here doesn't look like it captures the real structure very well. 5 looks better. I would believe 10. 10 looks good. I like it. 20 seems okay, but I'm starting to feel a little bit skeptical. At 50, I no longer believe this. And at 100, this is just silly. This is just silly. There's no reason to have 100 spline terms. So what's great about data visualization during the process of EDA is that we as machine learning practitioners can see and absorb this and use it to make decisions. And then those decisions are captured in code. So if you use Tiny Models code, these decisions may end up looking like this, with a feature engineering recipe with steps that transform and prepare the data to get it ready for modeling, whether that's dealing with factor levels, of which there were a zillion, or creating indicator variables, or setting those 10 spline terms. So whether it's for engineering new features or choosing an appropriate model or understanding data quality, data visualization during EDA has a huge impact on what model practitioners do later on. So in some ways, it is a foundation on which the rest of the model process is built. So it is often possible to estimate the best answer or value or option for some of these choices that we've talked about, like say the number of spline terms from the data using empirical methods. But it is nearly impossible to remove entirely the element of human judgment from these choices, or at least it's a bad idea. Machine learning algorithms are astounding. They are incredibly capable of learning patterns from large amounts of data. So vigorous adoption of EDA and visualization as part of EDA, as part of your broader machine learning process, is one safeguard against ending up in a situation where you have to ask yourself whether it was a good idea that you just deep fried your data. So let's move on now and talk about model evaluation. So this is that phase where we have trained and possibly tuned our models. So we have predictions coming out of the model to compare to true values, and then we can assess how our models are performing. And again, let's ask the same question: why are these plots built? So at a very high level, these plots and graphs are built to understand the models. More specifically, typically we start out assessing model performance. And we ask questions like, did this model work? Because this is the point at which we as model practitioners have to reckon with questions about success and failure. Machine learning practitioners often need or want to try out several different kinds of models, and model evaluation is when we compare models and ask which one performed best. We also are able to look at how models perform differently for different kinds of observations. The model evaluation allows us to interrogate subgroups. And this is typically where discussions of model fairness come in. A lot of the current work on machine learning bias and fairness focuses on how models perform differently for different groups. Perhaps for different legally protected classes that may not have been included directly in the model as a variable or input, but we may still see at the end that the model performs differently for those different groups. Model evaluation is also concerned with understanding why a model is making the predictions that it does. And we can ask questions like which model features are important in predictions. So for all of these questions, practitioners heavily use data visualization for a lot of the same reasons that it's used during EDA, which are largely the same reasons that anyone ever uses visualization. So these plots that are used to ask and answer these questions show relationships clearly that would be difficult to see otherwise, and they are supports and aids for making decisions that need to be made, like which model do I use? Or is this model fair? At the same time, there are some pretty unique things to note about plots used for model evaluation that I think are interesting to dig into. One is that a lot of plots used for evaluation involve graphical norms or idioms. So this plot shows two model evaluation metrics for a lasso regression model. So there's RMSE on the top and R squared on the bottom, and how they change with the regularization penalty, like how regularized was this model. So someone who is familiar with these kind of models and can look at this plot and can quickly gain a lot of information, can quickly recognize whether or not the model worked, whether it's a model that needs a lot of regularization or little, and looking at the R squared, assess how well, or in this case, not, the model fit the data. It's like a shorthand or an idiom that packs a lot of information for a familiar audience. This plot is similar. This is a receiver operator characteristic curve. Well, it's 10 of them actually, 10 ROC curves for a model trained on that Palmer penguin data that we discussed near the beginning. And what this plot is a visualization representing how well a binary classification model is doing. The more up in the left-hand corner the curves are, the better the model is doing. So the axes have the true positive rate and the false positive rate on them. And ideally, we want both of those to be good. We want the model to do a good job at both of those things. So this is another example of a model evaluation visual idiom that is familiar to modeling practitioners that can be used to compare models, assess a model, and so forth. So these kinds of visual idioms are a great fit for automatic plotting methods. When we talked about EDA, I highlighted the need for a really flexible plotting framework that can be used to create any kind of plot fluently. And hey, we should all adopt the grammar of graphics so that we can learn the grammar and then be able to create any plot we want in a really flexible way. So a lot of model evaluation plots are the same every time, and practitioners can be better served using shortcuts, these automatic plotting methods that are built by tool builders like me and my teammates, because it can be a hassle to copy and paste the same code for an ROC curve every single time. However, not all plots for model evaluation are these kinds of standard idioms that are considered normal or typical in the literature or practice. This is also a model evaluation plot for a model predicting the class of a volcano. And each hexagon shows the percent of volcanoes that have been classified correctly within that area on the Earth. So while knowing about some key automatic plotting methods are a useful part of the visualization toolkit for a modeling practitioner. Still, having that fluency in a flexible visualization system is really important. There's not always going to be an automatic method or one of these existing idioms to visualize model performance in the way that, that you need to. I focused so far on model evaluation plots that show us as practitioners how models are performing in terms of performance metrics like accuracy or RMSE or similar metrics like that. So some current work on model fairness falls in that category, but looking at differences in performance for different groups. Model evaluation activities can also encompass model explanation. And visualization is a key tool for explaining models too. There's model explanations fall into two main categories. And the first are global explanations, where we evaluate what features are important in a model's predictions overall. So this plot is from that data set of San Francisco trees again. And the length of the bars here correspond to how important that feature is in predicting the maintainer of the tree, whether the tree is maintained by the Department of Public Works or not, using a random forest model. And so this is feature importance globally for the whole model overall. So having a private caretaker is the most important. The spatial information is the next most important. So the random forest model was able to learn from the complex interactions of the spatial information. Where do we tend to have more Department of Public Works trees versus people, other people who maintain the trees. The other kind of model explanation is feature importance at the individual observation level. This is also called local feature importance. So there's multiple ways to do this. This particular plot shows an example of Shapley additive explanations for a passenger on the Titanic and a model predicting whether or not he would survive. And so the Shapley value is what's in the bars, what's shown there. So a Shapley value is the average contribution of a feature to the prediction in different combinations or what's called coalitions, but just for that one person. So the box plots show the distribution of the values and the bars show the average contributions for that individual. So for both global and observation level model explanations, these plots are used by the creators of the machine learning systems to evaluate and to understand them. So at this stage of the modeling process, we are again at a point of important human decision. And model explanation, together with model performance, can be used to make choices between models or whether a model is good enough for that purpose. And through this whole exploration of data visualization and the machine learning process, we've focused on plots made by system designers and operators for themselves as a tool to make better modeling choices. So these are plots made by practitioners for practitioners. Often discussions about data visualization center its use as a communication tool, and it 100% is. But in this case, we can explore some of data visualization's other functions, like its ability to use by system designers to understand the system more fully. Parts of the machine learning community this year, I've been really interested to see some exploration of what are called participatory approaches to machine learning, where system designers purposefully partner with the people impacted by the system, like what you might call users of the system, in shaping and designing the modeling system or the machine learning system. I think this is going to be really interesting to watch these ideas develop more, because that kind of practice and approach is going to have to impact choices through the whole model process, including what kind of plots we make to be able to like for what audience. And it may change the answer to this question, who are these plots for? What I don't think is going to change is the main purpose of any given data visualization during the modeling process. Some plots are created to help us understand the data that we start with, the input for the models that we create. So investing in data visualization to understand the input better is like laying a strong foundation. And some plots are created to help us understand the models that we create, the output. So careful visualization practices in model evaluation sets us up for success in models that are as accurate and appropriate and reliable as possible. And with that, I'll say thank you so much. I want to say a special thank you to my teammates on the Tidy Models team and the folks who make Tidy Tuesday possible, because most of the data sets that I showed today were from Tidy Tuesday.
Okay, Julia, thank you for your talk. I really enjoyed the energy. I'm really happy we have you for a keynote, and really good circumstances that you finished with the Tidy Tuesday hashtag at the end, because that's our first question, actually. Could you say a few more sentences about this? I know that this is something you post on your blog, but maybe people on our audience are not that aware of this hashtag and your actions.
Okay, sure. So the Tidy Tuesday project is largely maintained by Tom Mock, and it's a social data science project, and a new data set is released once a week, almost every single week of the year. And it's released either early Tuesday or sometimes late Monday or on Monday. And there's a data set once a week that then people in the data science community are invited to explore and share their results in some way. So it's a great way to practice data visualization, like we've been talking now, whatever kind of analysis skills you're wanting to work on or practice, modeling. I've been really excited to see some of the data sets that come out of Tidy Tuesday and be able to use them as some ways to demonstrate how to get started with tidy models. And I have some blog posts and some video screencasts that walk through how to use tidy models using some of these example data sets. But they're really general purpose data sets. And anyone who's working on, they span from, smaller to very large. They span on topic, from funny to serious. Sometimes they have text involved in them, which is always really fun. It's a great project to look into if you're kind of interested in like a social, community-minded way to kind of work with other people in the same week on the same project for something that's the data is there for you and ready to explore.
Cool, sweet, yeah, that sounds fascinating. Thanks for the explanation. There were a lot of comments and questions during your talk. One, there was a conversation about the usage of text mining data in a sparse format in a tidy text. Do you have any recommendations? Do you know about any plans? I saw Ken describing some plans, but I would like to hear something more from you as well.
Yes. So if you are dealing with text data, which I love working with and work with a fair amount, right now we have a support for pre-processing of text in a package called Text Recipes, which is maintained by Emil Wiedfeldt. And Emil right now are working on a new book, which is smalltar.com. It's supervised machine learning for text analysis in R, kind of a long name. So this book walks through how to do supervised machine learning for text. And it is tidy models, and then we're working on a part that's like the deep learning part using Keras. And so the specific issue of sparse data with text is one that I'm like, yes, let's talk about this. Because so if you use a tidy data principle approach to text, then you have your data in like a long data frame, and you don't have like, you're not keeping track of like all the zeros and the empty spaces, and you're often able to do text analyses in the EDA stage that you wouldn't be able to from like a memory format or something by using tidy data principles. When it's time to do modeling, then you want to cast to like a sparse matrix to be able to do the kind of machine learning that you want to. So right now, you can get out of a recipe a sparse matrix and then be able to do what you need to do to move forward. We're still working on the some of the infrastructure for model tuning and like kind of passing back and forth in the resampling for supporting sparse data structures. So this is high on our priority list in tidy models, is to be able to support those. Like I'm all in on Tibbles, like data frames, but there are some problem spaces for which you need a sparse matrix to be able to whereas like the model will just train like 10 times faster if you can represent it in a sparse matrix versus a non-sparse representation. So this is a high priority on our list, and I think you can look for more full support for sparse matrices in the near term.
Mm-hmm. That's really great. Yeah, I know that a lot of people faces the challenge of sparse representation because of the huge corpus that they have. So really happy to hear that there are future plans for the improvement. Julia, maybe one from the visualizations area for now. Do you recommend any interactive visualizations? Any libraries that you are keen on, or would recommend for a good start?
Yeah, so I think this is a really interesting question, interactive visualization. And I think it's especially interesting, say, let's step back and talk about what we talked about today. Like EDA and model evaluation. Is interactive? What do interactive plots get you that for a practitioner that fluency in a grammar of graphics might not be a better suited for, right? That you can like very quickly iterate because the code to set up some kind of interactive plot might be better served by quickly iterating in a static plot and making things. So I'm not that I'm saying interactive data visualization is bad, but rather where are you going to invest your time in what you're going to make? And then we come to model evaluation, right? We have some of the same kinds of questions. I do think that it is good to thoughtfully think about when is it going to actually help me? When is it going to actually help my stakeholders to do something that is interactive versus not? An interactive visualization, depending on how interactive we're talking about, right, is less guided and more, say, in the communication stage, and more. So if you like the point of your communication is like to make a point, then a static plot might be a better fit. I have really found it useful to use interactive visualizations in situations where like I want to have a hover, or I want to be able to interact myself, like in EDA, and so I think carefully about that is a good idea. My tool of choice is Plotly, and I really enjoy using Plotly. I've been kind of I have been interested in trying to invest a little more in learning how to use some of the other different ways of building interactive visualization. But sometimes when I have started, I've been like, okay, given what I actually spend my time doing is what's a better use of my time, right? And it's like, so I want to reflect back to like what I said for a machine learning practitioner, like what are the goals, what are the purposes, and like when do I like what's the payoff? Like what's the payoff?
Got it. That totally makes sense. Yeah, there are trade-offs of every approach. All right, we've got a couple more. Maybe this one regarding the color blindness. Do you have any recommendations for people with color vision problems? Is there a standard approach? Are there any palettes that we should avoid?
Okay, so there are some great, I'm gonna have to look up the name of it. There's an R package that allows you to send in your plot and then get out what it looks like in under different kinds of color blindness, which is really useful for checking something when it's going to go out to a broad audience. And when it's going to be going out in as like you're using visualization as a communication tool. So that is really helpful to look. We've seen that the rainbow color palettes are not as good, that we can use some of these more grounded, well-researched color palettes that are available, some of which are available in the, whatever visualization tool you use, like people are integrating them as defaults more, which is really great to see. I think this is an interesting question to think about when visualization is being used as a tool for a machine learning system builder, and how, like, then the kind of that question we talked about before, like who is this plot for? And if we're gonna balance, like we want, like, do I want to be aware of the challenges and stay up to date on my options, or do I want to over optimize something that I'm using for my own tool building? Like what do I want to and so if I have a particular need, I'm going to build something in one way, but then like who is that plot for? And to honestly answer, like, is this going to end up in a report or somewhere? And then I do need to think about like what are the practices that I use there? So that balance of like honestly assessing, is this a plot just for me, or is this a plot that is going to get broader broader viewership? I mean, I feel like often I have been more surprised by plots getting out more broadly than I thought they would than the other way around. And so I think that is a good reason to learn about and have a toolkit of things that are aligned with best practices in terms of accessibility.
Mm-hmm. Mm-hmm. Okay, thank you for the reply. Yeah, this is always a good take-home message to keep in mind. Who is the final receiver of the plot? So yeah, that depends. That depends on the receiver if it comes for the standards. So there's one that is really close to this topic. If you do a plot for a report, which means there is a broader audience, how many iterations does it take normally to end up with the plot that satisfies you? And do you rather work it on your own, or do you brainstorm with a team?
Yeah, I So one interesting aspect of using a like grammar of graphics based system is that question of how many versions did I make? I think is hard to answer because you make, and you like add. And because you're like a sentence builds uses a grammar to construct a sentence, and like to use a grammar of graphics to make a plot, you like add, change, shift. That, but we're doing, I'm doing it all at once, like I'm sitting here, right? Like, okay, add another line, change this. And so, I think it would be difficult to answer how many sort of versions were there before there was one that's like, oh, okay, that is communicating what I want it to communicate. I think that's a difficult question to answer because the intermediate steps, there are so many, because there are so many that I guess one way to say is like, I never just like type out like, oh, there it is. I just typed it out one time, made a plot, and it's done. It's like, okay, we add, take away, add to make a plot. In terms of getting feedback and then sharing out for communication, I have rarely pair programmed for data visualization, but I think that'd be pretty interesting to do as a practice to kind of understand how to do that and get someone else's input in that. But I have often shared a report or a plot or something in a before sending something to stakeholders. So I guess one of those is more rare, and then one of those is quite common.
Yeah, totally makes sense. That's for sure an iterative process, and we are perfectionists, so we keep making more iterations to make that even better. Julian, there's one last question. There's a really vivid conversation, but regarding the topic of the sparse content that we already described, but I also see one regarding to the text mining. Where was it? Oh my, there are so many of them. Yeah, can't find this right now. Oh yeah, there it is. And I thought that's a good one. I'm also a text mining practitioner, so I think this will help a lot of people in the future as well. So there's a question regarding a text mining and tokenization. Do you tokenize before or after you split the data? And is there any difference? Does it matter?
That's a great question. I think that there's room to have some differences on this, but I think the safest option is to split the data first and then tokenize, because tokenization is part of your like feature engineering and data pre-processing. And if you have like a pipeline or a process that tokenizes first and then splits, you can end up with situations. It's very easy to make subtle mistakes and end up with data leakage, or include or not include features that you don't mean to. Or to have a pipeline that does or does not account for new tokens that you see or not. And so splitting before and then tokenizing forces you to build a pre-processing pipeline that is going to be more robust. So I think there's So I know Ken Benoit, who's going to give a talk tomorrow, actually just wrote up a really great Stack Overflow answer on this that I thought was really interesting. That kind of says like, here's one reason why you might do it one way and one reason you might do another way. My opinion is that the sort of safest baseline is to split as raw of data as you can. And that includes untokenized text data, and then to build a pipeline that is robust to, for example, missing tokens, new tokens, that kind of thing.
Okay. Yeah, this makes sense. So split the row as soon as possible and get the pipeline immune to new tokens. That makes sense. And talking about Ken, he was very active on the chat, and yeah, you're all invited tomorrow for his talk at what's gonna be 1 p.m. UTC.
That'll be great.
That would be great.
Yeah, you should all come see Ken.
Julia, that's all for today. Thank you for joining. I really enjoy your energy, and I was really happy that you agreed to give this keynote talk. Yeah, so let's call it a day. Thanks.
Great. Yeah, thank you so much for having me. It was such a pleasure. And thank you so much to the YR organizers for all the work you've done getting this ready.
Okay, and for the participants, let's focus on challenges at the text mining, and let us know if the description and data sets are clear. And see you on YR Foundation Slack. And if you go to our website, 2020.yr.pl, you can find information about upcoming talks, text mining hackathon, and a way to join our Slack.